I'm working at Rakuten Institute of Technology in Tokyo. I have been in charge of research and development for cloud storage, LeoFS, since its inception in 2010. As you may know, LeoFS is open source software which is posted on GitHub. URL here. So there are 6 things I'd like to cover today. First, I will introduce overview of LeoFS. Then I will share brief benchmark report. Then I will introduce much data center replication as of powerful features. Then I will introduce NFS Support as one of the new features. Then Aras Patel, he is in charge of LeoFS support and administration for Rakuten. He is talk about LeoFS administration at Rakuten. Finally, I will share future plan of LeoFS, which is version 2.0. Let me move first topic, overview. There is a reason why I started the LeoFS project. As of October of 2009, I expected we will be faced with exponentially increasing data in the future in Rakuten. So we needed to be able to store and manage huge amount and various kind of data at low cost. In addition, total data capacity in Rakuten will reach exabyte by 2020. Unstructured data such as image, movie, log, and so on, they have been increasing more and more because we have living Internet of Things era. I think if you look at the big idea at LeoFS, what we are really focused on is 3 things. First one is high availability. We aim to realize 9/9 operating ratio, which means allowed downtime ratio of LeoFS is few seconds a year. It's a very serious figure. Second one is high cost performance ratio. We may be focusing on reduction of storage costs, so we need to realize high performance with minimum resources. One more important thing is high scalability. We need high capacity, huge capacity, in order to handle suddenly increasing data and huge traffic, and need multi-data center replication for disaster recovery. As you can see on this slide, we have really succeeded in designing and implementing LeoFS as simple as possible thanks to this architecture. Administrators are able to easily install LeoFS, and LeoFS can be viewed as one huge storage from users. In addition, LeoFS is a software-defined storage, which is called SDS, which means LeoFS does not depend on any hardware and OS. In addition, LeoFS consists of 3 core components: gateway, storage, and manager. So each component is clearly defined. I'm going to introduce them later. What I carefully designed LeoFS is to satisfy 3 high things: high scalability, high availability, and high cost performance ratio, and to provide easy administration for administrators. First component is LeoFS Gateway. Gateway consists of first HTTP server Alan Cowboy, API handler for REST, and S3 API, and object cache mechanism. Thanks to S3 API, you are able to easily access LeoFS with S3 clients such as Dragon Disk, S3 Command, and programming language clients, Java, PHP, Ruby, and so on. Regarding message flow, a client requests gateway to storage cluster. A destination node is decided by the routing table, which is called the link. It's based on constant hashing. Furthermore, gateway provides built-in support for object cache mechanism, which is contribute to keeping high performance and reduction of network traffic between gateway and storage. Next component is LeoFS storage. Both write and read operation depends on the link routing table to realize automatic replication and repair of data. Requested objects are automatically replicated into the storage cluster, and also inconsistent objects will be fixed eventually. LeoFS absolutely keep consistency of an object eventually by their function. LeoFS storage consists of object storage and metadata storage. Regarding metadata storage, which manages and stores attributes of an object, it depends on KVS, key value store. We are using LeoDB and Alarm Bitcast. On the other hand, object storage, which manage and store metadata and actual data, which are stacked in object container. I'm going to introduce the data structure on the next slide. As you can see on this slide, metadata consists of file name, file size, offset, version, timestamp, and so on. Regarding middle, which consists of metadata, actual data, and footer. There is a reason why this format. LeoFS storage need to recover metadata from middle. And object container, which consists of plural needles. This format is log structure file format. This format is robust and high performance because the effect of local file system is just a little. But LeoFS storage need to remove unnecessary object by data compaction mechanism. Last component is LeoFS manager. LeoFS manager always monitors node status and link hash of every storage and every gateway node. Or keep running LeoFS and keeping consistency of the distributed link. And also, manager generates a link and distribute to gateway and storage nodes. Actually, we already provide the GUI control, which is called LeoFS Data Center, and CUI script, which is called LeoFS admin script. We took LeoFS benchmark with 2 cases. Let me share the detail. We took benchmark with 2 cases. Number of storages is 5. Number of gateway nodes is 1. Number of manager nodes is 2. And read and write ratio is 9:1. Difference of second case is only read and write ratio, which is 8:2. This slide is server spec of gateway and storage nodes. CPU is G1 processor, memory is 96 GB. Network is 10 Gbps network. Storage data capacity is 2 TB and RAID 0. This slide is environment. OS is CentOS, Alarm and LeoFS is like this. The system consistency level is number of revelation is 3. Successful write, number of write is 2. And other like this. And benchmark compilation. Duration time is 4 hours. Number of concurrent processes is 64. number of keys is 100,000, and there is 4 value size groups from 1 kilobyte to 1.5 megabytes. In our company, range of object size is almost between 1 kilobyte to 1.5 megabyte by 80%. So we adapted these value groups. This slide is result of the first case. Operation per second, 500 operation per second without errors. And both step and put mean latency is 50 milliseconds. It is good results for us. In addition, we use Fasho page as a benchmark tool, which is dependent on ARM. In case of this, the traffic will reach 6.5 gigabps into the 10 gigabps network. Gateway spends the processes on the network traffic, which is 60% of overall rate. That means LeoFS gateway contributes to keep performance and reduce network traffic between gateway and storage nodes. This slide is the result of memory usage and CPU load average for 5 minutes. Gateway spends the memory on object cache. As I mentioned, LeoFS gateway has object cache mechanism. Space spent on the memory from OS page cache. On the other hand, CPU load average for 5 minutes. CPU load from those results. It seems LeoFS performance is stable. CPU load average almost less 1.0. Next is second case. In this case, comparison with the first case. Its only difference with first case is read and write ratio, which is 8:2. The second case result is operation per second about 1,000 without errors. Get latency is 65 milliseconds and put latency is 85 milliseconds. It is good result for us. From next slide, I'd like to share a comparison of first case with the second case. This slide is comparison of network traffic between first case and second case. As a result, second case was 0.7 gigabps lower than first case. What was the cause of the performance degradation? First cause is this slide. This slide comparison of disk utilization between first case and second case. As a result, second case was 1.8 times higher than first case. Second cause is this slide. This slide comparison CPU load average for 5 minutes. As a result, second case was 1.6 higher than first case. Also in second case, both disk utilization CPU load average were higher than first case. So I want to say that your base bottleneck is disk I/O. In conclusion, there is in the stable performance through the benchmark. Bottleneck is disk I/O, and the detection mechanism contributes to reduce network traffic between gateway and storage. We have been published LeoFS benchmark report on GitHub frequently. If you will have LeoFS performance, please do check them. Next is about Data Center Replication. We provide this function with LeoFS version 1.0. It is one of powerful features. As I mentioned, the former, we need multi-data center replication for disaster recovery in order to keep data despite significant disruptive events such as earthquake, like earthquake. We supported this mechanism with LeoFS version 1.0 on this April, and this function satisfies high availability and high scalability with this function as simple as possible, there are three important features. First one is the easy operation to build clusters with LeoFS manager. Second one is asynchronous data replication between clusters. That data is transferred to remote clusters with asynchronous processing. Third one is to recover inconsistent objects eventually. So I'm going to introduce how the multi-data center replication operates between clusters. First, preparing the multi-data center replication. First step is to execute the join cluster command on the manager console in order to communicate local cluster and remote cluster. Then every manager will begin to monitor remote link and system configuration each other. It is necessary to keep to communicate with remote clusters. The next step is stacking object. A storage is required to replicate an object in the local cluster, left side, right, and then an object is stacked into an object container to realize asynchronous object replication. One container's capacity is 32 megabytes. You are able to change this configuration at LeoFS switch. When the capacity is full, switch sends stack object to remote clusters with asynchronous processing. The next step is transferring stacked objects. We are the asynchronous data replication between clusters. A stacked object is compressed by D-4 library to reduce network traffic as much as possible. A remote cluster node automatically replicates the object into one cluster, similar to the way of the data replication at local cluster. Next is about investigating stored objects. First, the node of the local cluster is received metadata of the stored objects. Then, storage compare them between clusters, local clusters with remote clusters, in order to fix inconsistent objects eventually. The storage found inconsistent object, which are stacked into the object transfer container again for recovering inconsistency. The storage repeats this cycle in order to fix inconsistent objects between clusters. In conclusion, an object keeps consistency eventually by this mechanism. As I introduce this function, you are able to easily build a multi-cluster storage system by this function. Next topic is NFS support, which was realized at LeoFS 1.1. We are aiming to centralize huge amount and various kinds of unstructured data in LeoFS. We thought we needed to support both S3 API and REST API for online transactions, such as web services, and NFS support for backend services, such as big data analysis and search system. We have been to realize data hub which is needed to our company. The function is the alpha status we have been increasing gradually. Next topic, LeoFS administration at Rakuten. This topic talks about Aras Patel. He is in charge of LeoFS support and administration. He is going to talk about this topic. Please go ahead.
Good afternoon, all of you. Myself, Aras Patel, in charge of LeoFS administration at Rakuten. So today I am going to talk about use cases of LeoFS in many ways. For example, storage platform, file sharing services, end user servers, portal site, photo storage, and background storage of OpenStack. So this is one greatest example. So the media is powered by LeoFS over here. So due to some confidentiality and privacy issue, I cannot illustrate the real-time use cases in Rakuten. Let me talk about the external user other than Rakuten. So this is a project FIFO. It's open source. It's open source SmartOS. So project FIFO is a cloud management and orchestration system for SmartOS virtualization environment. The components of FIFO are written entirely in Erlang, and LeoFS is also written in Erlang, which gives the suite excellent stability and fault recovery as it continues maturing to the production quality releases. Project FIFO uses LeoFS packages for SmartOS in the repository. So this is our greatest achievement to acquire third-party user. So let me talk about the storage platform team. So Rakuten is a company providing many types of services: e-commerce, portal site, recruiting, insurance, blog, and so on. In order to support this kind of services, we are developing many platforms. For example, platform as a services like a Heroku, infrastructure as a services like a AWS EC2. We also having a search platform and storage platform. So regarding storage platform, we are using LeoFS and provide the platform with S3 compatible APIs. So that means if you are an existing customer of Amazon S3 and you would like to migrate your data and you want to use LeoFS in your private data center, then welcome, LeoFS is only for you. There were some requirements for the storage platform team. First is a cost reduction. Comparing with existing storage, the price was down over 75%. Second is a high reliability. Before building the storage platform, we have been operating beta version of LeoFS since last 2 years. We have find so many bugs and solved all these problems, and now we having a very stable version of LeoFS in market. Third is the scalability. LeoFS does not need special specification servers, so we can prepare the LeoFS cluster very easily and scalable way. Storage platform scaling the storage platform. Our many services are using backend photo storages. The data of the storage is being migrated to the LeoFS. The total usage of the backend photo storage is around 450 terabyte. The number of files are 600 million. Total disk volume is increasing 100 GB per day. The traffic of storage is 13 million requests per day. This is the layout of the storage platform team which we are managing currently. Thanks to the Erlang and thanks to the LeoFS simple and greatest architecture, it having a infinite n number of horizontal scalability on each layer like a gateway, storage or manager. The cluster includes 4 gateways, 14 storages, 2 managers. Total disk space currently is 600 terabyte. We assume 800 Mbps access as a max value. In addition, we are using Ganglia and NugOS to monitor these servers. This is the overview of monitoring system for the LeoFS. Ganglia processes are collecting the data and visualizing the data in forms of the graph. NugOS is checking the port and checking the values on Ganglia graph to notify the error situation. Ganglia is collecting not only OS resources like a CPU, memory usage or network, but also SNMP values which is extracted from the LeoFS and visualize them like a number of objects, number of replication messages, etc. NugOS is also checking SNMP values of LeoFS to notify the errors immediately via using Atlassian HipChat as well as mail. The platform is hosting currently in Japan right now. We want to expand this platform globally and cover more and more services with multi-data center replication. If we could provide it, the latency will decrease and availability will increase more and more. So next use case is a file sharing system. This is my project R-Drive. We are using LeoFS, OpenCloud and Roma. All technologies are open source. I am a big fan of open source. So basically LeoFS and Roma both are powered by Rakuten Institute of Technology. It is developed entirely from scratch to top in the Rakuten Institute of Technology only. So we are using this open source technologies. With the expansion of the company, we want to share the confidential data more smoothly in internal. Furthermore, to share the information more directly, people want to share videos. For example, we hold a company-wide meeting every Tuesday, known as Asakai. For example, some group companies are difficult to attend the meeting at the same time due to the timeline issue. To solve that issue, we record the meeting and share the meeting as a video. For this requirement, our team constructed this file sharing system, which is known as a R drive, and which is, you can take example of Dropbox, similar kind of application we have built up. OneCloud is a file sharing web application, which is also open source, implemented in PHP. Now users are sharing their videos to the group of companies. Connected companies are over 20. The system getting access from 10 countries now. The DB is stored over 10,000 users and 4,000 teams right now. Actually, we are working with 10,000 employees, so the number of users will increase more and more gradually. This is the system overview of the file sharing system for the R drive. For example, we are using Roma. Roma is a key value store entirely written in Ruby to store the login data and adapt to authentication and authorization. WebGUI is powered by OneCloud. Metadata storage is by MariaDB, and storage core of the system is powered by LeoFS. Continuous automated testing. So each and every new commit of whenever we get new commit on LeoFS repository, we have built automation testing using Jenkins. So each and every new feature will be tested on each and every commit in various languages like AWS. All the SDKs are provided by Amazon S3 in various languages like PHP, Ruby, Java, Python, Erlang, S3 CMD, and S3 Fuse. So that means we have a real-time testing scenarios. We want to expand the system to cover all the group of companies and all our employees. Finally, my presentation is going to complete over here. I would like to give a chance to Harasan, and we having one exciting announcement for the open source lover at the end of the presentation. Thank you.
Next topic is LeoFS version 2.0. This concept is beyond the storage system covered cloud storage. One of LeoFS concept is high availability. So we are planning to provide the mechanism for LeoFS version 1.2. Always keeping best condition of LeoFS. First one is autonomic operation, which is to realize minimizing administration tasks as much as possible, such as rebalance and data compaction. Second one is QoS, quality of services. We are planning to provide the LeoFS insight for keeping high availability, which will be included in statistics of internal LeoFS and request traffic control mechanism with watchdog. And also, we will support web GUI of Leo Insight on Leo Center. So we aim to support and implement hybrid storage with LeoFS version 2.0 in order to centralize huge amount and various kind of data in LeoFS, which means LeoFS supports both online transaction and offline transaction. So we have been working on implementation of NFS server from LeoFS version 1.1. Currently, this function mechanism is alpha status. So we needed to implement lock option and improvement of performance, retrieving content list like the ls command, Linux command. So as you can see on this slide is the blueprint of LeoFS version 2.0. LeoFS 2.0 consists of LeoFS Insight and LeoCenter. LeoInsight is quality of service system, QoS. It is based on new database project, database. And it is focusing on time series data and data analysis in real time. On the other hand, LeoCenter, which is LeoFS Web GUI console, currently version is 0.4.6. And also, I consider a better platform can be LeoFS integration with OpenStack. But currently, OpenStack integration is planning phase. We will deeply consider that after release the next version. So we are aiming to realize and provide truly cloud storage with LeoFS version 2.0. So I have one more topic. We started a new database project at the beginning of April this year, which is LeoFS spin-off project and still no name. Actually, at the beginning, I was designing and developing it was for a QoS database. So, but I decided to start a new database project, which focusing on time series data and real-time analysis for huge amount of data. Because I recognize new database is required from data analysis engineers platform. So there is a reason why I started a new database project. We needed to get value in huge amount of data in real time, but we does not really realize that yet. Typical system realize semi-real time or batch data analysis, not real time, because the way of data analysis of a typical system spend much time for the processing. For example, first handling the data analysis, the data transaction, and then analyzing data. Finally, analyze data stored into the cache or database. So spend much time. We are planning to realize this function in real-time data analysis with new database project. There are 5 important design principles in order to realize getting value in data in real time. First one is analyzing data in real time, which is to realize delivering value in exponential data. Second one is ad hoc query. We will provide programmable query language mechanism. The first phase, we are focusing on implement of SQL-related function, such as SQL parser and SQL planner, query planner. Third one is machine learning and such library integration, which is to realize generate value in exponential data continuously. And high reliability and high scalability, similar to LeoFS. So new database consists of four components and one GUI application. First component is online transaction, and second component is programmable query language. As I mentioned, we are focusing on SQL as first phase. So after that, we are planning to implement with programmable query language. So we include JSON language. Previously, Edison mentioned is spec and design. And third one is unstructured data storage. The third one is analyzing data. Continuously generated data with statistical and machine learning library. important thing is data visualization. Now I'm planning to implement Grafana or Grafana integration. We are planning to release the first version of new database as open source software early next year. Please look forward to that. So, LeoFS, as I mentioned, LeoFS is open source. We provide all LeoFS source code on GitHub. And we provide manual page of LeoFS for LeoFS version 1.0.